Okay, today we're going to use our knowledge of perfect squares and extend that to learning about perfect cubes and their roots. So first of all, just a short review on perfect squares. A number is a perfect square, such as 9, if it has two identical factors. Okay? And we know that we can write 3 squared as 9. You can also write that as the square root of 9 is 3, which is the reverse form, the inverse form. Alright, now it is true that 9 can also be written as negative 3 squared, because negative 3 times negative 3 is 9. Okay, so actually any positive number will have 2 square roots, but for right now we're just going to talk about the positive square root. And in fact, whenever this symbol is used, the square root symbol, we're always going to mean that we only want to talk about the positive square root, even though there are actually 2 square roots for any positive number. Now another way to think about a perfect square is visually, and the term square isn't accidental, because when we have 3 squared, we can think of that as a square that's 3 units by 3 units, and if I fill that in with squares, I would have 9 squares on the inside. So the inside area represents the value of the 3 squared. So again, we have 2 ways to think of perfect squares, and if I look through my list of perfect squares and just pick any one of them, 49 is a perfect square because it has 2 identical factors. Or the other way I could think of it is if I had 49 little blocks, I could arrange it so that the side length would be a whole number. Okay, we'd have 49 squares on the inside, the area would be 49, and the side length would be 7. So I'm going to use what I've talked about to figure out whether or not 1764 is a perfect square or not. And I'm going to use the idea that a perfect square has 2 sets of identical factors. I'm going to do this without a calculator, so I'm going to use prime factors. I could simply type it into the calculator and I would know whether it's a perfect square or not, as to whether or not my answer came out to a whole number or not. So 1764 can be broken down to 2 times 882. 882 can be broken down to 2 times 441. 441 to 3 times 147. 147 to 3 times 49. And 49 into 7 by 7. So when we're all finished, my prime factors are here. I have 1764 is equal to 2 times 2 times 3 times 3 times 7 times 7. So is this a perfect square or not? Well, remember, a perfect square means that my number can be written as the product of 2 identical factors. Now I have all the prime factors listed here, and if I look at them, I could break them up into combinations. I could take one set of 2 by 3 by 7 and another combination of 2 by 3 by 7. And just wondering what this number is here. 2 times 3 is 6 times 7 is 42. So therefore, the positive square root of 1764 is 42, which means that if I had a square with 1764 little squares in it, I would have side lengths which were nice whole numbers, 42 by 42. So yes, it's a perfect square. Alright, now perfect cubes are numbers that have 3 sets of identical factors. So 1 times 1 times 1, 1 is a perfect cube. 2 times 2 times 2, 8 is a perfect cube. And so on. All of these numbers are perfect cubes. And just like with perfect squares, I have an alternate notation for writing this. I could write the cube root, so I'm going to use the same symbol, but I'm going to stick a little 3 in between the little check mark sign kind of, and say the cube root of 1 is 1. The cube root of 8, in other words, what times what times what is 8? 2. And so on. The cube root of 27 is 3. Okay, this number down here, by the way, we call the radicand. The little number here is the index to remind us that we're cube rooting. When we're square rooting, we don't put a number in this position. You can think of, with square roots, you can think of a 2 being there, but it's usually typical not to write anything. Another way to interpret perfect cubes is to think of a number as, guess what, a cube. So if I take 8, which is 2 cubed, I can think of this as a 2 by 2 by 2 cube. And if I block it off to show my units, I would have 8 cubes contained in that. In other words, the 8 can be thought of as the volume. We're in 3 dimensions now. The answer to a cube equation is the volume, and the base here would be the side length. Okay, so a perfect cube of a whole number can be represented as the volume of a cube with a whole number edge size. By the way, on your calculator, if you want to do cube roots, so for example, if you wanted to check out does the cube root of 8 equal 2, and under the math menu, math, press number 4, cube root of 8. So if the volume was 8, what would the side length be? It would be 2, and since 2 is a whole number, 8 is a perfect cube. Alright, let's use factoring to determine the cube root of 2744. And again, I'm going to use the idea here that a cube root means that the number can be expressed as the product of 3 identical factors. So to identify the prime factors, let's do our factor tree. 2 times 1372, that breaks down to 2 by 686. That breaks down to 2 by 343. 343 is 7 by 49, and 49 is 7 by 7. So we end up with 2744 is the product of these numbers, by 2 by 2 by 7 by 7 by 7. And the question is, can that be broken up into 3 groups of identical factors? Well, it can if I take 1, 2, and 1, 7 for each grouping. So 2 by 7 times 2 by 7 times 2 by 7. In other words, 14 times 14 times 14. It's worked out evenly. I've got 3 identical factors. Therefore, the cube root of 2744 is 14.